Welcome to Maths for You channel. Past questions on differentiation. Let's start with first question. Y equal x to the power of 3 minus 4x squared minus 3x plus 9. At the part A, find dy over dx. dy over dx equal 3x squared minus 4 times 2x minus 3 times 1 plus 0. That is equal to 3x squared minus 4 times 2, 8x minus 3 dy over dx. Let's look at part 2 or part B. Find the range of values of x for which y is increasing. In other words, the range of value of x when dy over dx is greater than 0. So dy over dx is greater than 0. In order to get the value or find the range of x values, let's find the critical value for us to argue. Easy to find it. So critical value dy over dx equals 0. In other words, 3x squared minus 8x minus 3 equals 0. To find the value of x is quadratic equation, and therefore factorize it. So easy to factorize it. This is how I do it. So factors of 3x squared, this is 3xx, and factors of 3, that is 3 and 1, minus 3 and 1, so whereas minus comes in is here, and plus 1. So 3 times x squared, 3x squared, minus 3 times 3x, 9x, minus 9x, plus x, so that will be minus 8x, and minus 3 times 1 is minus 3. So the factors are 3x squared plus 1 and x minus 3. So the values here, x equal minus 1/3 or plus 3. So let's analyze the outcome to find the range. Minus 1/3 and plus 3. So we can actually get 3 different areas to argue. Minus 1/3. So the value is less than minus 1/3. The value is between minus 1/3 and 3. Value is greater than 3. So value from minus infinity to minus 1/3. Value is from minus 1/3 to positive 3. And value is from 3 to positive infinity. So 1 is minus infinity to minus 1/3. And second one, minus 1/3 to positive 3. And third one, positive 3 to positive infinity. Let's look at the first one. Find a value between those two range. So let's take minus 2, x equal minus 2. If I could substitute that value minus 2 to dy over dx, as we said, the range of x when y is increasing mean dy over dx has to be greater than 0. So first value you're going to substitute is minus 2. If you could substitute that value to dy over dx, which is 3x squared minus 8x minus 3. Minus 8x minus 3. So if you could substitute the value, that 3 minus 2 squared minus 8 minus 2 and minus 3. That is minus 4, that's 12. Minus 2 squared is 4, 3 times 4 is 12, and this is plus 16, that's minus 3. 12 plus 16 is 28, minus 3 is 25, is greater than 0. So this is the right value. So the x will take that value range. And second one, between minus 1/3 and 3. Say, let's say x equal plus 2. So again, 3 times 2 cubed minus 8 times 2 minus 3. So not cube, squared. 4 times that is 12 again. Minus 16 minus 3 minus 12 minus 16 minus 4 minus 7. That is less than 0. So the x will not take that value between minus 1/3 and 3 because of y is increasing. Third one, x equal, say, 3, say 4. Squared as 8 times 4 minus 3, that is 16, 3, 48, as 32 minus 3. 48 minus 32 is 16, minus 3 is 13. So 48 minus 3, that is greater than 0. So the range of x is between minus infinity to minus 1/3 and 3 to positive infinity. So we can write it as this: minus infinity 1/3 3 plus infinity. That's the range. First part of first question done. Second question, a curve has an equation y equal 2x to the power of 3 plus 9x squared minus 24x plus 13. Find the coordinates of the curve's local maximum. So y equal 2x cubed plus 9x squared minus 24x plus 13. Let's check that again. Y equal 2x cubed plus 9x squared minus 24x plus 13. Correct. To find the maximum value, local maximum value or minimum value, let's go into, we'll have to differentiate and find the turning points or the critical value. So dy over dx equal 2 times 3x squared plus 9 times 2x minus 24 plus 0, or 24, 1, 0. That is equal 6x squared minus plus 18x minus 24. To find the critical value or turning point values, that is dy over dx equal 0. So 6x squared plus 18x minus 24 equal 0. If you could divide everything by 6, it'd be easier. X squared plus 3x minus 4 equals 0. So factorize this. let's do this way. X, 4, 1. So x squared, x times x squared, 4 times 4x, positive 4x, and negative 1x, so the positive 3x, minus 1 times 4 is minus 4. So x minus 1, x plus 4. So that two values. So the value x equal 1 or minus 4. Two values. So we need to find the right value for local maximum. So we don't know which one is local maximum value for. So let's start with x equal 1. But having got that x equal 1, to find the maximum minimum value, we need to go into the second order differentiation, then find the sign of that. Y equal, that gives you 6 times 2 times x, 18 times 1 plus 18 times 1. That is equal 6 times 2 is 12x plus 18. So if you apply x equal 1 or substitute x equal 1 here, d2, so when x equal 1, d2y over dx squared equal 12 times 1 plus 18. That is equal 30. That is greater than 0. But d2y by dx greater than 0, therefore x equal 1 is at minimum point, local minimum point. What we need, the coordinate of local maximum point. So let's see the second one, x equal minus 4. So dy over dx, dy over d2y y over dx squared equal 12 times minus 4 plus 18. That is equal minus 48 plus 18. That is equal minus 30 less than 0. So x minus 4, at x minus 4, it will be local maximum. So the local maximum, the coordinate local maximum, so local max at x equal minus 4. But I need to find y coordinates. So y equal, we can rewrite that equation, y equal 2x cubed plus 9x squared minus 24x plus 13. So if you could substitute x equal 4 here, minus 4 here, y equal 2 times minus 4 cubed plus 9 minus 4 squared minus 24 minus 4 plus 13. 4 to the cube is 64, it's minus, and times 2, so minus 128. 4 times squared is 16, minus 16, and times 9, that is minus 144. Plus, because of minus 4 squared is plus, so plus 144. Minus 24 times 4 minus 4, that will be plus 96 plus 13. So minus 128 and 144, which will give us plus 16. Plus 96 give us 112. 112 plus 13, 125. So the maximum point coordinates is minus 4, 125. Thank you.